Okay, so we continue with the next example. So for this, we have a more complicated expression in terms of to differentiate them. Okay, so here, as you can see, you are given a two variable function and you have to find the partial derivative respect to x. Alright, so here you can see that you got two functions and they are multiply each other. So it looks like you have to apply product rule. Okay, so I give you some time for you to try, maybe about 3 minutes, and then maybe I will call you to share your answer and post in the maybe in the group, and I will present through my screen. Okay, could you please try first? Just a product rule sama macam sebelum ni. No major difference, but the only difference now you have to deal with y, because now you want to differentiate with respect to x, so y you have to assume constant. Okay, so but the process product rule, the formula is exactly the same as shown here. Product rule. If you have any question, just ask directly. Maybe I would prefer you, if you want to comment or you want to ask, just use your microphone. Just open the mic. Just unmute, I mean, because I cannot check the chat box straight away. So you all guys semua dah ada dekat hometown masing-masing dah ke? Ada yang masih ada kat UTM?
Dah.
Patutlah dah tak nampak student dah dekat UTM ni. Lapang je. Bas pun kosong je. Okay, anyone who want to give a try? Ada yang dah siap? This one a bit longer because of the product rule. But I think to differentiate is not so difficult. Any volunteer? Dah siap? You guys. Dapat tak? Saya tahu jawapan dah ada tapi macam saya sebutlah sebelum ni, you have to working on it by yourself. The answer given just for you to check the step and maybe the answer. Any volunteer? Okay, so kita ada section 4 hari ni. Heidi Syukri ada dalam ni. Heidi Syukri. Ada tak orangnya? Ahmad Rizalman. Ada. Ni ramai tak datang ni. Macam mana ni? Topik ni masuk test Week ni, so topic covered for test 1 until this week 5. Aisyah Dalila. Semua tak ada ke? Azim Iqmal Riza pun tak ada.
Ada doktor.
Siapa ni? Azim ke?
Azim.
Dia dah siap lah.
Dah.
Dah siap. Okay. Willing to share the answer?
Sekejap.
Dia dah send ke Telegram ke?
Saya letak dekat Telegram.
Sekejap. Okay. Thank you. Kejap. Saya... Sekejap saya nak check participant dulu. Sekarang ni berapa orang yang dalam? Semua dah 47. Okay. Okay, ni so this one the work done by Azim. Okay, let's stack together. Uh, so we have this one. Alright, so here we apply the product rule. So this is the product rule. So the u is the first function, and the exponent function is the v. Sorry. Okay. So now we find the because the question asking for partial derivatives with derivative respect to x, so we have to find the ux and then vx. Okay, so ux y constant, so the first term become we differentiate this, so you got 4. Okay, so for ux, so we got 4x and then y plus 3y squared. Okay, and then for vx, okay ke warna merah ke you all punya? Saya tukar hitam lah. Okay, so differentiate v respect to x. So here, this is a composite function. The outer function exponent and the inner function is 5xy. So we have to apply chain rule actually, but macam saya sebut sebelum ni, kalau you just a single layer, biasanya kita terus congak lah, just a direct answer. So we differentiate the outer function, we got we got we got the function back. So e5xy multiplied by the derivative respect to x, the inner function, so you got 5y. So that is a vx, and then we substitute the based on the product rule here. So we have the u times the vx. So this is the vx. Okay, so this is from Azim, it's correct. And then v, so just copy v, so this is v, and then ux, so he got this. And then we expand that and simplify, so we get some particular form. Because of the question here asking you to at the end to evaluate, so we don't bother about the final version of your answer here, whether you factorize like this or you just leave your answer like this. We don't bother about that, because the thing that we are bothering is the final value, because you have to evaluate the derivative at x equal to 1 and y equal to 1. So by replacing all the value x and y, okay, don't forget here e. So when you replace xy to be 1, so you just got e5. E5 is a constant, okay? So we got the 32 e5. So any one of you got a problem here? Still any other part yang unclear? So okay, so far so good. Please respond. Okay, can I proceed to the next example? Hello?
Boleh doktor.
Okay, thank you. Okay, so the next example. So this kind of example is favorite in the whether test or final exam. Remember, as I mentioned just now, our test 1 will be covered till chain rule week 5. So kalau you tengok dekat you punya course information, course information, this one. Okay, you tengok dekat part week 1 to week 5. So what is the topic that you have to prepare for your test 1? So all the chapter 1 will be in the test 1. And then plus last week you have a part of partial derivative. And then today, I mean this week, I hope that we can finish till the chain rule. So we have a webback class today, and for the next class on Tuesday, I will give you videos. So I'm very sure that we can finish the chain rule for this week. So, and also in the e-learning, I already shared to you some of the sample. I gave you the tutorial question, tutorial 2, and also the sample question from sample exam question. You know, you are the first batch. If you're asking me the past year question, so I don't have that copy because you are the first batch using the new syllabus. So I just give you a sample exam question that I'm taking from other courses. But the question will be more or less like that. Okay, just the level of difficulty will be the same. Okay, so back to the example 6. Um, so example 6, what we have here, you have to find the del f del y for the given function. Alright, so just like the exponential function just now, you have the inside the exponential, you have the another function. So for this, you have a logarithmic function out ln, and inside the ln there is a x plus y function. So you have the two layers of functions. So in order for you to differentiate partially for the given function here, so you have to apply chain rule. Okay, so chain rule, the simple idea of chain rule is if you have two layer, so you differentiate the outer function, differentiate the outer function times or multiply the derivative of the second layer of function. So here you have ln, the outer you have ln, so you differentiate ln. So biasa kalau last time for single variable, if you have ln x for example, so what is the result of the derivative respect to x for ln x? Apa jawapan dia?
1 over
1 over of what?
2.
I mean they're just ln x. So I give you if I just give you uh just a simple function ln x. So when you differentiate dy over dx, so what is the result? Just now,
1
what
over x.
1 over x, yes. So similarly for this, okay, let me copy the function. So here you have ln of x plus y. Okay, so we differentiate the outer function. So the outer function, just ignore whatever in the bracket. So we have 1 over x plus y. Okay, and multiply or times the derivative of the second layer. So the derivative of the second layer with respect to x of x plus y. So here remember when you want to differentiate respect to x, so y constant. So what is the result from it from this? So we differentiate x, we got differentiate x dapat apa?
1.
Alright, okay, plus. Okay, now differentiate y respect to x. So what happened? Y constant. Differentiate constant dapat apa?
0.
Yeah, you got 1. So times 1. So you got 1 over x plus y. That's it. Okay. So that is for very simple expression. But normally in exam you have maybe 3 layers. So that one after this I will teach you for multi-layer and multi-variable or multi-parameter. If you have more than one parameter and if you have more than one variable, so how can we deal with that? So still kita panggil dia chain rule, tapi sebab dia dah multi, dah berlapis-lapis, dia ada spesifik cara lah you nak kena dapatkan dia punya chain dulu. So I will teach you later. Okay, so because you all masing-masing kat tempat masing-masing kan, so I cannot ask you to discuss, but maybe just 2 minute. Can you try yourself first? About 2 minute. Dapatkan dulu. Tengok apa you dapat nanti dan kita bincangkan. Oh, this one. Okay, you done? Okay, Ain, Erina ada dalam ni? Ain? Kalau tengok dalam list participant ada orangnya. Ain, Erina?
Yes,
Dah siap dah?
belum.
Belum. Siapa lagi? Any volunteer? Daniel. Ada nama Daniel ke dalam? Okay. Daniel Fitri ada. Muhammad Daniel Fitri. Dah siap? Daniel nampak ada tu dalam ni. Ada tak orangnya? Kerja on je Webex tapi dia pergi ke mana-mana. Okay. Mungkin dia punya mic dia rosak kot. Siapa lagi ada dalam ni? Ikmal. Ikmal ada tak?
Saya ke?
Okay, dah siap Ikmal?
Belum.
Belum?
Belum.
Hmm. Siapa lagi? Siapa yang dah siap? Ada yang nak share? Kita sama-sama. Ada yang nak share? Tak ada? Okay. So, tak apalah. Nak tunggu semua. Takut tak habis, tak terkejar pula exam punya. Okay, kita tengok. Kita buat sama-sama lah. Okay, so you have xy squared cos of xy. So you want to get the partial derivative respect to x. So you got two terms here. Okay, the first term you have xy squared. So differentiate respect to x. So you only have y squared plus. And the second term, the x is inside the cos function. So this is called composite function. The outer function is cosine and the inner function is xy. So first, this one we need to apply chain rule. So what chain rule says, you have to differentiate the outer function. So we give you, what is the derivative cos respect to x ke apa? Contoh macam y cos x. So differentiate dapat apa? Dy dx.
Sign. Negative sign.
Yeah. So for that, meaning that you got negative sine of xy. That is the outer function times the derivative of the inner function xy with respect to x. So we only have y. So meaning that we have this. So you have y squared minus y sine of xy. So
Dia
that is
tak
the
jadi zero
fx.
doktor.
Yang mana tu zero?
Yang sign tu.
You mean yang ni ke? Ini. Okay, dia because of this is chain rule. Okay, chain rule sebab dia composite function and x tu terletak di dalam cosine function. So you kena apply chain rule. Chain rule kata differentiate the outer function. Cos jadi negative sign, tapi sign of sign of what? So sign for everything in the bracket. You just copy. We don't bother about the second layer function. We just bothering on the outer, the cosine. So maknanya di sini bila you differentiate cos, you akan dapat negative sign of whatever in bracket you copy. Okay, and then multiplied by the derivative of the inner function terhadap x. So xy bila differentiate terhadap x, you dapat y. Itu saja. Faham? Boleh ke?
Okay. Kasih doktor.
Okay. So the second one, fy. So again, we look at term by term. So the first term will give you 2xy. Okay, and then for the second term, y also inside the cosine function. So we apply the chain rule again. So derivative of the outer function should be the same seperti yang tadi lah, sama. Sebab function yang sama, so negative sign of xy times derivative of the inner xy terhadap y pula. So you akan dapat x by x constant for this one, fy x constant. So differentiate xy, y jadi 1, x kekal lah kat sini sebab dia constant dia coefficient. So when we simplify, we got 2xy minus x sine of xy. Okay, so what is the... Okay, you just differentiate that without evaluating. So any question? So maybe our answer got a contradiction and you still tak clear. Okay, boleh
Boleh
All
doktor.
good? Alright. Okay, so we go to the next. Alright, so we go to the next part. All the example that I showed you just now and last week, they are all about first order. First order. So actually, we can have a higher order. So when you differentiate once, so we call that first order. When we differentiate twice, dua kali, two times, so you can say second order. And you differentiate third time, and you can say that third order and so on. So the way of writing. Okay, look at here. Okay, saya terangkan kat sini lah. Through my iPad. Kalau saya nak counting terus. Chapter 2 part 1. Oh, nota saya tak sama dengan yang tadi. Saya pun yang mana tadi. Oh, yang lama betul lah. Okay, okay. Kita tengok yang masih bagi yang terbaru. Okay, before we proceed with the higher order, I want to show you this example first. So this is another exam-like question. Okay, you look at the example here. You are given the function. Then you have to show this expression where the expression containing the term of the partial derivative respect to x and respect to y, and you have to show this expression. So when we talk about the showing question, soalan yang something like proving lah, macam you nak kena proof lah expression ni sama ada boleh tunjuk pada kiri ke kanan atau kanan ke kiri sepatutnya. Okay, so for this case, it is more informative if you start with the left expression to obtain the right expression. Sebab kalau you mula daripada right expression, so you have no idea. Sebab you just to multiply the f given, and then how can you show the partial derivative to the left? So normally for this kind of expression, we try to work from left side to show the right side. Understand? Okay, so what is in the left side? So in the left hand side, there are partial derivative f respect to x and respect to y. So firstly, you have to differentiate partially f respect to x and respect to y. So because of we have the fraction form, so you have to apply the quotient rule or division rule. So that's why kalau tengok dia punya jalan kerja dia looks quite tedious because of you have to apply the quotient rule. You tahulah quotient rule dia panjang sikit sebab dia melibatkan division Okay. So can you spend for 2 minutes maybe try to figure out yourself. So here your u should be your numerator part. So this is your u, and your v should be your denominator. And you have to find because you have to you have to find the partial derivative respect to x and y. So meaning that you have to find the u respect to x and also u respect to y. Similarly for v, so this is v. Then you have to find the vx and also vy. So after that, you substitute into the quotient rule. Okay, can you try first? Okay, u x squared y squared. So we want to differentiate respect to x. So y constant. So x squared become 2x and then y squared. So next, respect to y. So x constant. So you will have 2y x squared. Okay, and then v is x squared plus y squared. So we find the vx. So differentiate. So you can see the x here alone, x squared. So when you differentiate x squared, you got 2x. And then y here, because y squared is alone, just alone, no x. So meaning that all this term y squared also constant. So differentiate the constant respect uh, because the x, so y constant. So differentiate constant, you got 0. That's why you only have 2x. And vy x squared is 0. Differentiate x squared, you got 0. And you have 2y. Okay, now we substitute into the quotient rule to get the del f del x. Applying the quotient rule, v u x minus u v x divided by v squared. Okay, so v is x squared plus y squared. Ux is 2xy squared. Negative u is x squared y squared. Vx is 2x divided by v squared. Okay. So we try to expand and then simplify. So we have 2x cubed y squared plus 2xy 4 minus 2x cubed y squared divided by x squared plus y squared. So this one the same. So we got 2x y 4 x squared plus y squared. Don't forget, this is v square. Okay, so we go to the del f del y now. So now with respect to y, so v u y minus u v y over v square. Okay, v is x square plus y square. Uy is 2y minus u is x square y square, vy is 2y divided by x square plus y square square. Okay, so expand and simplify. So 2y x square plus 2y cube minus 2x square y cube 2x square y cube divided by x square plus y square square. U V V Y So macam ada mistake. Click double check. U
UY dengan VY sama.
okay. So this is V U Y this U this V1 apa tadi? Siapa yang cakap tadi?
Doktor, UY tu 2x 2yx squared tu.
Di mana atas UI yang dekat yang mana? Dekat yang ni, term, second term.
First,
UI yang ni. V okay, UI. What is UI? Okay, thank you. Okay. 2y x square. Okay. So 2y x4 plus 2y cube x square. So this is going. So we got 2y x4 x square plus y square square. Alright. Okay. Still unfinished ya. Sebab soalan tadi minta kita prove this expression. So kita baru halfway. So now you have to multiply based on the you obtain just now fx and fy. Now you have to multiply fx with x and fy with y. And see what we've got. So x times fx. X times fx, you got 2xy 4 over x square plus y square square plus y times fy, so 2y x4 over x squared plus y squared squared. Okay, so we have to show by multiplying this one and adding both term, we should have 2f. Kalau you tengok kat sini, you should have 2f. So what is 2f? 2f is 2 times f, so your f is x squared y squared over x squared plus y squared. So you should obtain this one. Okay, you should obtain this when you simplify this one. Okay, you should obtain like this one. Okay, so now we try to simplify what we got here. 2x square y4 plus 2y square x4 over x squared plus y square square. Okay, so you can see x, y, and there are two here. You can factorize 2, factorize 2, and then you can have x squared, and you can factorize x squared as well. So apa yang tinggal? Yang ini akan dapat just x squared you dah keluarkan, y squared you keluarkan, yang tinggal y squared saja. Y4, y squared you dah factorizekan kat sini, so yang tinggal y squared saja. Okay, now the second term. The second term, when you factorize 2, so the 2 gone, and you take out y squared, so y squared here gone. X4 you take out x squared, so yang tinggal x squared. Divided by x squared plus y squared squared. Okay. And as you can see, kalau yang this one, kalau you tulis balik, dia sama sebenarnya dengan yang bawah. So you akan dapat 2x square y squared x squared plus y squared over x squared plus y square. So you can cancel out this one, simplify. So ini tak ada lah. So you got 2x square y square over x squared plus y squared. So this one is same as 2 times f. So should. Okay, I wrote here this one just to guide me, to guide what is our expectation when you simplify this one. So ini sepatutnya kemudian lah, cuma saya tulis awal sebab nak membantu kita guide ourselves to the next direction to get the result. Okay. So this is exam like question bentuk macam ni biasa juga saya jumpa dalam test dan juga final. Okay, for final topic differentiation still can be asked in the final exam. Cuma sketching cuma domain saja yang tak dalam final. Dia cuma dalam test 1 saja. Tu domain and ring. Okay, do you have any question? If there is no question, so we move to the next part. Okay, so give a try on this. So this is exam question with 4 marks. So this is from exam question, but I'm not sure test or final. It can be either one. Okay, so be careful when you read this kind of expression. So some students they read this wrongly. They just assume that f times y over x. It's not right. Okay. So this is actually you want to define a function z in terms of f. So z is a function of f. And inside the f there is another function which is y over x. So this is called a composite function. The outer function is f, but we do not know what is the outer function. It can be any function. This one written in general form. Okay, but inside the function f, there is another function which is y over x. So you have to show this expression. So obviously you have to show from the left, you got the right, you got the answer 0. So we have to find out the partial derivative respect to y, respect to z for this given function. So how we can write down, because this one biasa you jumpa, you tahu outer function dia apa, dia specific. Contoh you can have the sine of y over x, or you can have ln of y over x. So you know exactly the outer function is. But for this we do not know. It is a general. So how can we write down? Macam mana cara nak tulis kalau you ada soalan yang bentuk macam ni? Okay, so this example, you have a function z. Z is a function of y over x. It is not the same as you read this to be z is y over x. Different Yang ini cuma single layer saja, z is y over x. But this one, z is a function where the outer function is f and the inner function is y over x. So they are not the same. They are not the same. So you have to read this just like composite function. The outer is f, the inner is y over x. So you have to find out the del z, del y, and also del z, del x. Okay, firstly, let's see, we start with the del z, del x. del z over del x. Okay, now we apply chain rule. Okay, when we have a composite, we always have a chain rule to differentiate. The method, okay, the method that is applicable here is a chain rule. So differentiate the outer function. Macam mana you nak differentiate outer function? Kalau you ada ln, you akan dapat 1 over everything in the bracket. Betul tak? Betul ke? Kalau you ada ln of y over x. So when you differentiate the outer, you will get 1 over everything in the bracket, and then multiply the derivative respect to x of the inner function. But for this one, because we do not know exactly what is f, what the f is, so you can just write down f prime. So when you have f prime, so we understood that we have to differentiate that, but in general form, f prime of everything in the bracket. So we just leave like that. Okay, so the derivative of the outer function f, we got f prime, then times the differentiation of the y over x, so del x of y over x, y constant. So what is the result? What is the derivative of this respect to x where y is constant? Berapa jawapan dia?
1.
Satu. Satu saja. Anyone want to try? X tu kat bawah y per x, y over x. Kalau x dekat atas, then you boleh kata 1 lah, x jadi 1. Y fix.
Negatif 1.
Okay. Thank you. So, actually, you can, okay, y equal to x is the same as y x minus 1. Betul tak? Betul kan? Cara macam tu. Okay. So, kalau you nak differentiatekan terhadap y, sorry. Terhadap x, sorry. Terhadap x. Del x of this one. Y constant, right? Y constant. So, differentiate x to the power minus 1. So, dia akan jadi apa? Power dia akan bawa jadi perkali lah. Jadi, negatif 1 times y. X, power dia akan berkurang 1. Jadi, minus 1. So, you got minus 2. So, you will get negative y over, okay. So, negative y, x minus 2. So, biasa kita tak suka ada kuasa tu negatif. Kita akan tulis balik kepada bentuk yang asal. Kuasa dia positif. Jadi, awak just tuliskan negatif 1 lah kat atas. X tu akan jadi 1 per x kuasa 2. Okay? Ada soalan kat sini untuk part ni? Ini teknik differentiation yang sepatutnya saya tak perlu repeat di sini sebab ini teknik yang you pernah jumpa sebelum ni. Cuma mungkin terlupa and kita jarang guna, so you tak mahir. So pastikan make sure that you really can do very well for your differentiation teknik ya. Untuk you untuk pastikan jawapan awak tu betul lah. You punya background, skill untuk differentiate tu kena ada. So how can you have the skill? You have to do a lot of exercise regarding differentiation. Okay. So that is the derivative of the inner function. So this is not the answer. This is wrong. So this is what I'm talking about. So we substitute here. Okay, just now I said that differentiate the outer, so you got f prime times the derivative of the inner function with respect to x. So this is the result. So negative y over x square. Okay, that is for del z del x. Okay, next, del z del y now. Del z del y, so similarly differentiate the outer function. You will have the similar form f prime of y over x times the derivative of the y over x respect to y. Okay, sekarang y dekat atas, x constant. Okay, del y now of y over x. X constant. X biarlah dekat bawah ke kat mana-mana tapi dia constant. So we don't bother about that. So apa jawapan dia?
1 over x.
Yes, that's correct. 1 over x. So this time you don't need to boleh nak tulis bentuk ni juga tapi dia tak affected pun sebab you x tu constant. So kalau you differentiate terhadap y, so dia akan y dapat 1, so 1 times x minus 1 or 1 over x. Okay. So this one 1 over x. So then we substitute into the expression that you want to show where zy times y. So y del z del y. So this is from the question. Tengok balik dalam awak punya nota. Dalam soalan dia minta kita tunjukkan expression ni y del z del y plus x del z del x and show it is 0. So now we have already obtained the del z del y times y. So you have y times f prime of y over x divided by x. Ni yang ini. So ini adalah f prime of y over x divided by x. Okay. Plus x time f prime, kita ada negative y plus no time. Okay, x negative y f prime of y over x divided by x square. So when we simplify, we have y over x f prime y over x minus, so this one cancel, square gone, so we have y over x f prime of y over x. So we got 0 because they have a similar form. So it is shown. Okay, ada soalan? Siapa di dalam ni? Farhanis? Okay? Boleh? Farhanis ada tak? Okay, good. Hairul Nazmi? Can you respond? Okay? Or not okay?
Okay, doktor.
Alright. Monica? Monica okay? Tak dengar. It's okay. Alright. So thank you for your response. Okay, now we go to the higher order. Okay, higher order. So here we have a second order first. Second order means you differentiate twice. So we know that when you differentiate once respect to x, for example, you have del f del x. We write down that to be fx, right? So now we want, okay, you differentiate once, you got the new expression, right? And next you differentiate again using the recent form, the recent expression. you differentiate that again with respect to x. So using that result, so you differentiate that again with respect to x, which means like this. So the del x is the mathematic language. So but in our language, so we just see that the derivative of the first order derivative with respect to x, or in the simpler form you write down to be like this. So you settle down the first one fx, and then using that recent form, you differentiate that again with respect to x. You have this one. Okay, so means that if you use this form, so the first left telling you the first derivative that you obtain. Kalau kat sini you tengok x yang paling kiri lah, the first left paling kiri. So you differentiate yang x dulu. Contohnya kalau saya bagi you another derivative, so f x z. So maknanya apa ni? Siapa yang kita kena settlekan dulu? Z dulu ke X dulu? Which one will be the first? X or Z first? What do you think? Okay, the first left is the first derivative. So meaning that you settle down the fx first. Dah dapat? Gunakan result yang terakhir. Next, differentiate terhadap Z pula. Contoh terhadap Z pula. So itu maksud dia lah. So let's say I give you another second order derivative. Yx. So who comes first? Y or x?
Y.
Y. Okay. You find the fy first and then differentiate that with respect to x. But kalau kita itu kalau dibagi dalam bentuk yang simpler form macam ni lah, f of yx or f xy. Tapi kalau katalah dalam soalan dia bagi you dalam bentuk macam ni. So we know this one second order sebab dia ada kuasa 2 kat situ. Itu sebenarnya datang daripada sini lah. You settle down, you differentiate f respect to x first, followed by y. So bila kita expandkan dia, permudahkan dia, so del you will have del squared f. And then the denominator become del y, del x. So kalau macam ni, kalau saya bagi bentuk del y, del x ni, siapa dulu? Nanti dah confuse. Dia tak, cara baca tak sama macam simbol yang f, x, y or yang kecil ada subscription macam ni. Subscription macam ni. So kalau yang subscription macam ni, yang paling kiri is the first. Okay, the first left is the first derivative that you have to obtain. However, for this particular form, dia lain pula cara baca dia. Yang paling kanan is the first. So, nanti bila exam jangan terkeliru sebab jawapan dia akan berbeza. Jawapan akhir dia akan berbeza kalau melibatkan higher order. Okay, so I repeat, for this subscription form, the first left is the first derivative followed by the rest lah. Okay, x dulu and then y. Kalau berdasarkan based on this example, you differentiate terhadap x dulu and then y. Okay, but kalau dibagi dalam bentuk simbol macam ni, yang paling kanan is the first. Yang paling kanan, yang ini, this one. This is the first. You differentiate terhadap x dulu and followed by y. Differentiate terhadap x dulu, followed by y. Okay? So hopefully you don't mix up the notation used here. So kena bear in mind lah, kena ingat Okay. Look at this one. Fyx. So means that you settle down the y first. You settle down the y first and followed by the x. And followed by the x. They are the same process but different notation. Okay, understood? Hopefully you clear with that. But for fyy, for xx, we don't bother because differentiate terhadap variable yang sama. So we don't get confused for that. But if they mix, this is called mix, partial derivative mix. Dia second order, tapi dia bercampur variable. Terhadap x, terhadap y, terhadap ataupun sebaliknya. Tu kita panggil mixed partial derivatives. Okay. So there is one theorem says that for second order, this is only for second order derivative. Okay, as we know that you have two variable function. If you have two variable function, z is the function of xy. So the partial derivative that you can obtain is f respect to x, f respect to y, and for the second order, fx, and again using the same variable ffx, similarly fy and then y, and you have the mixed partial given by fyx and also fxy. So this is the possible partial derivative that you can have for two variable function. But there is one special special rule or special property for these two guys. For these two. Sebab kalau you tengok yx, xy. So this is called mixed second order partial derivative. They have a special result where their result is always the same. xy or yx. Which means that for this one, you settlekan x dulu. Lepas tu y. Ataupun you settlekan y dulu, then x, they will have the similar answer. When you substitute, when you want to evaluate the value at the similar point xy, you will have the similar value. Semua for any kind of the variable function, fxy and fyx, they have a similar value or similar form. Only for second order. For third order, fourth order tak ada. Ini untuk second order sahaja. So dia sentiasa sama. So you have to remember this. Okay, we look at the computation regarding the second order derivatives. Okay, look at this one. So here z is defined as two variable function. Z is a two variable function. As given here, find the indicated partial derivative. So here you have del square z, del x, del y. Okey, ingat kalau dia bagi dalam bentuk del ni, siapa dulu? Y dulu ke x dulu? Kena tengok yang paling kanan. So, you have y, meaning that you have to settle down for y first. So, I put y here and followed by x. You have z, y, x. Okay, you have to find the second order derivative. Okay, number 2. Del square z, del y, del x. Look at the first right. The first right is x, so meaning that you solve for x first. Find the partial derivative respect to x, followed by y. Okay, and the third one, you have del square z, del x squared, so meaning that z, x, x. And the fourth, you have to evaluate the fxy, so this one, at the point 2, 1. Okay, so to answer this, so I don't want to show the result obtained in the slide, so we do it together. Okay, example 2. So we have z is given by 7x cubed minus 5x square y plus 6y cubed. So first you have to find z, y, x. Okay, so to get that, you have to find the z, y first. Find the derivative z here respect to y. So the first term there is no y, meaning all the term here constant, so it is 0. So 0 minus differentiate y, differentiate y, you got 1, so you have negative 5x squared only. And the third term, so you got 18y squared. And now you can obtain the derivative of this one. So macam mana sebenarnya, apa yang berlaku kat sini kalau you nak cari second order? So you differentiatekan sekali lagi. So using the recent form, which is you have zy now, and using the result of zy, you differentiate this expression with respect to x pula. Okay, because we have a second order, you differentiatekan dua kali tapi terhadap berbeza pemboleh ubah. Yang kedua adalah terhadap x. So now zy and differentiatekan terhadap x. So you will get, okay, look at the first term here, you got negative 10x. And then the second term, there is only y, because you nak differentiate terhadap x, so y constant, so this one 0. So the answer is 10x. Faham? Boleh? Fatin Dalila, okay? Boleh faham? Nur Fatin Dalila. Boleh, Doktor? Okay. So that is the first question. So we go to the second question. We have to find out the z, x, and then y. So to get that, first you have to differentiate z with respect to x first. Okay, using the z, differentiate yang ni terhadap x, so now you got 7321 x squared. And this one, y constant. So y constant, so we don't change the y. So we get negative 10x y. And the third term, there is only y. So all these constant, so it's 0. Okay, so you done the first zx, and next differentiate the recent form of the zx here. Differentiate this with respect now to y. I mean differentiate that now with respect to y. So zx and then y. So the first 0 because x constant. Sekarang you bezakan terhadap y. So x constant. So this one 0. And this one you differentiate terhadap y. So yang tinggal negative 10x. So now you see, you can see that based on the theorem, it says that zyx always equal to zxy. You can see the expression here, they are the same. This one, zyf, is the same as zxy. They have the same form. This is in agreement with the theorem. Okay, they are always similar. Okay, back to the question here. So we got the same, negative 10x. Here we go, number 3. Number 3, we have to find the second order where you have zx and then x. So gunakan result zx yang you dah kira tadi, yang ini, zx. Gunakan yang zx ni, sedia ada. And differentiatekan sekali lagi terhadap x. So ni jadi berapa? 42 lah. 42x. So you got 42x minus the second term, there is x inside. So differentiatekan terhadap x, you dapat negative 10y. Okay. And the fourth, we have to evaluate f xy at point 2, 1. So this is x and this is y value. So we have to replace into the fxy, the second one here. So we have negative 10 and then x saja yang kita nak. Y kita tak ada. So we got negative 20. Any question? Ada soalan? Ni kalau tak ada, we go to the next question. So this exam like question, another proving, you have to show from the left you got the right. I mean, you have fx minus, so this one is fx minus fyy, and the answer is 0. So you have to find the fx. So fx, you got 2, right? 2, differentiate this respect to x, you got 2, this one 0, and then minus e minus x. Okay, be careful with this one, the third term. Terconteng ke, Azimah? Ke you willing to jot down something? So I decline, Okay, be careful with the third term. Looks like there are two functions and they are multiply each other. But you have to be careful here. So the first part, you just have x, and the second part, you have just y. So if you want to differentiate respect to x, so here cos y considered constant, so we don't change that. So we just differentiate e minus x, so that's why you get negative e minus x times cos y. Okay. And then what we need, what is the thing that we are looking for? So the second part here, fy. So you have to find the fyy, but first you have to find the fy. Fy. Now differentiate respect to y. So the first term 0, the second term becomes 2y. Okay, now e minus x constant, and then cos y differentiate, you got negative sign. Negative e minus x sin y. Okay. Kenapa ada negatif? Sebab cos you differentiate cos dapat negative sign. But e minus x does not change because that is constant. Okay, now because we have to provide the second order. So what you have to do is differentiate that again with respect to y. This one, differentiate this with respect to y. So you got 2 minus e minus x, differentiate sign, you got cos of y. So we substitute into the expression. So fx minus fyy. So fx, you got 2 minus e minus x cos y minus fyy. So 2 minus e minus x cos of y. So we expand. So 2 minus x cos y minus 2 plus e minus x cos of y. So cancel out all the 4 terms. So we got 0. Okay, remember you have to show this one. Now by replacing all the terms that you obtain, and you manage to show from the left, you got the right. And it is shown. Okay, so let's say in the question asking you to you have to deal with third order, for example. This is another example. So let's say I give you f, find under f, x, z, y, for example, and then x again. So this one we call this fourth order. Fourth order, okay? 1, 2, 3, 4. So fourth order. So first differentiate the expression, the original expression respect to x, and you have fx, and gunakan result daripada fx. Now we differentiate that respect to z, And now using the result of f exact, you differentiatekan terhadap y dan seterusnya terhadap x. Okay. So just keep repeating. I mean, the process, the differentiation process, but your expression should be different sebab you gunakan the recent form. Jangan guna yang asal. Dia dah tak betul lah. So gunakan you punya recent derivative form. Okay. Ada soalan kenaan dengan higher order?
Betul.
Ya.
Yang FYY tu macam mana boleh jadi dua?
Okay. Okay. FY1 maksudnya you dapatkan dulu FY. So you dapat result FY you dah kira. Yang ni faham kenapa dapat ni? Ada masalah?
Faham.
Okay. So gunakan result yang ini sebab sekarang you nak differentiate kali kedua, second order. So maknanya use the recent form which is FY. Gunakan FY punya result ni. So yang inilah. So berdasarkan ini you differentiatekan terhadap Y. So bila bezakan terhadap Y, X constant lah. Macam biasa kita assume X constant. So to Y differentiate to Y dapat 2 lah. Boleh? Faham?
Faham.
Okay, so the second term X constant, so E minus X ni tak berubah, still ada. And sign, differentiate sign Y terhadap Y, jadi cos Y. Okay, okay, ada lagi soalan sebelum saya pergi ke slide lain? Saya guna earphone ni, bising tak? Ada noise tak kat belakang?
Tak ada dah tu.
Tak ada. Clear lah. Okay, thank you. Okay, tak ada soalan. So, kita pergi ke chain rule. Okay, you dah biasa guna chain rule ni. Bila you pakai, kalau you ada composite. So, apa tu composite? Rasa macam saya nak faham apa tu composite. Dalam fungsi ada fungsi lain. Okay, last time we use just a simple chain rule. Without kita develop dulu chain dia. You know kenapa nama dia chain rule? Chain tu chain lah, rantai rantaian dia punya flow dia, flow antara variable ke variable yang lain. So kita panggil chain. And how can we have rule? So a formula, rule is the formula. So what is the rule? The rule is this one on your right side, where you already apply that long time ago. You pernah jumpa ni. Saya tak tahu dah jumpa. Saya dah pernah diintroducekan belum dalam masa you sekolah. Saya tak ingat lah yang tu Cuma saya tahu differentiation dah diajar. So of course lah chain rule tu perlu ada kan. Jadi mungkin you dah jumpa ni dah lama. So kalau you just ada 2 layer, contoh macam just like you have Z, you have Z is given by okay, Z is the sine of x squared plus y. So you have 2 layers. Outer is the sine function and the inner is x squared plus y. So if you want to get the derivative del z del x, for example, you kena lalu dulu dia punya outer function. So what the rule said, what is the chain rule said, differentiate the outer function. So differentiate the outer function, you got cos of what? Cos of everything in the bracket. You don't change that. Times, so now dot ni maknanya kali lah, times the derivative of the inner function. The derivative of the inner function is x squared plus y. Bezakan terhadap x, so you got 2x. So that is your result using chain rule. So untuk case yang simple macam ni, okay, ada setengah student yang memang dia very cepat macam kereta api, so dia just congak je dapat jawapan. Okay, ada student yang sebaliknya dia buat satu-satu. So tak kisahlah kategori mana awak, asalkan you follow the rule, you akan dapat juga jawapan akhir yang betul lah. Okay. Cuma yang ini yang biasalah, just 2 layers. What if you ada yang lebih complicated? Contohnya, okay, I define Z is sine of x plus y. But x tu sendiri, X pula dalam sebutan parameter. Contohnya T kuasa 2. You know, dalam X ni ada function lain pula. Dalam Y ni ada function lain pula. Y is 1 over T. So macam mana you nak 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 cari derivative dia? Dah pening dah. Jadi you kena tahu macam mana nak develop the chain dulu. Dan daripada chain tu you akan dapat rule. So you akan dapatlah chain dulu je. Okay. So don't worry, tak susah pun. Okay, ni contoh yang paling mudah. Okay, because we are talking about you are learning about two variable function, so we have two variable function now. And then each of we know that inside the Z there are X and Y, but inside the X and Y, each of them there is T. And then the X and the Y is defined separately. Contoh macam saya bagi tadi lah. Macam saya bagi tadi. So Z is defined by X and Y, but X and Y defined separately in terms of T. So macam mana you nak dapatkan dia punya partial derivative? So to get that, so this is the rule, but don't need to memorize this. Jangan menambahkan you punya memory space. Sebab ada cara mudah untuk you tahu nak tahu macam mana dapatkan rule ni. Rule ni maksudnya formula ni lah yang sebelah kanan ni. But the most important thing is you know the chain. Macam mana nak dapatkan chain ni? So how it's work? Like I mentioned just now, based on this is chain. Boleh ditulis dalam bentuk horizontal macam ni. Okay, ada juga kalau you Google, dia akan tulis dalam bentuk vertical. Vertical maksudnya dalam, ni daripada kiri ke kanan. So, horizontal. Kalau daripada atas ke bawah, dia panggil vertical lah. So, kalau untuk case tu, saya buat vertical. So, atas sekali Z. So, inside the Z, there is two variable X and Y. And inside the X, there is T. And inside the Y also there is a T, but different function lah. Sebab tu kita buat separate. Okay, sama saja kan? Cuma saya tulis dalam bentuk vertical, ini horizontal. Okay, how can we have this rule? This is called chain. This is called change. So the formula of the partial derivative is called rule. So the combination we call that as a chain rule. Okay, so how can we have this? You can just like you have four terms. First, you have to have Zx, del Z del X. Second, you have the dx over dt. The third, you have del Z del Y. And the fourth, you have dy dt. So, how can we have this one? Kenapa ada darab? Ni darab Ni darab. Ini Z. Ini dengan ini dia darab. Tambah yang ini dengan yang ini dia darab. Okay, itu maksud saya. So, macam mana kita dapat formula tu? Saya gunakan ni lah tu. Senang saya nak explain. Okay, so just now I said that Z, and below the Z there is X and Y, and then under the X there is T, under the Y there is T. So we want to get the, just now they said that dz over dt. Kenapa now kita panggil D? Kenapa tak panggil del? Okay, nanti saya explain. Kenapa you tak letak? Kalau saya tulis del Z over del T, kenapa salah in terms of notation? Why it is wrong? That is because, okay, anyone want to answer, kenapa kita guna D for this case? Why we don't use del for only dz over dt? Kenapa saya tak guna del Z over del T? What do you think? Kenapa you tak guna? Awak rasa kenapa?
Because yang guna T tu only one variable.
Yeah, that's correct. Because you see, yang paling atas is the boss. Ada satu Z kan. So, pekerja yang kat bawah sekali tu, seorang je. I mean, representing by one parameter T. Tak kisahlah parameter ke variable ke, tapi single. Satu je. T dan T. Sama kan T dan T. Jadi, sebab dia satu je parameter or variable. So, that's why we have dz over dt. But in between, kalau you tengok formula dia tadi, in between, silap. Kalau you tengok formula yang sebelah kanan, ada combination D and del. So, that's why you have to understand D means standard derivative. Sebab it containing one parameter on one variable. But del, when you have del, it is representing that you deal with more than two variable or two parameters. Tapi dalam when you want to calculate, it can the notation can be combined. Okay, so okay, how to construct the formula? Okay, now you want to go from z to t. From z to t, how many root that you can passing through? How many roots? How many paths? How many ways from z to t? Ada berapa? Imagine awak ni daripada z awak nak pergi ke t, ada berapa laluan yang you boleh ikut? Based on anak panah ni, anak panah lah ni. Ni anak panah lah ni. Tapi saya tak buat.
Dua.
Okay, you got two routes, two way, two path. So, two routes mean dalam you punya formula akan ada two terms. Kalau three routes, three terms here. Okay, now you have two routes, dua laluan. X dengan Y melalui X dan melalui Y. So, in your formula, you should have two terms. This one and this one. Okay, the first term, laluan yang pertama, katalah laluan pertama you nak pergi daripada Z ke T melalui X. So, daripada Z ke X, because we know under the Z, there are two variables, so we use the notation del Z over del X, or we call that as a ZX. Okay, and for the other root from Z to Y, we have del Z over del Y or ZY. So, yang ni kita panggil del sebab dua melibatkan two variables. Okay, now from X to T, because there is only single root, single parameter under the Y and under the X, so we just use dx over dt. And this one dy over dt. Okay, now look at the formula of the first term here. Yang pertama ni. So, you nak pergi Z ke T, you kena melalui del Z del X dan melalui dx dt. Sebab dia punya laluan dia sama, so you kena darabkan dia. Del Z over del X times dx over dt. Okay. Now, kalau you faham how you can construct the first term and you can have the second term. Second term means second root. Daripada Z, you nak pergi T melalui Y. So, from Z to Y, you have the del Z del Y. And from Y to T, you have dy dt. So, you just multiply them. Del Z del Y times dy dt. Del Z del Y dot dy dt. That's it. So, you dapat formula tu. Okay, mungkin you masih blur because this is just the first time you heard about this. So, but when you have another chain rule, multi layers of function, then the way you construct the formula is the same. Okay, kalau you ada 3 cabang, so you tambah lagi satu kat belakang, tambah lagi term. Tapi darabkan. Laluan yang sama you kena darabkan. Pada laluan yang sama you kena darabkan. Laluan berbeza you kena tambahkan. Itu maksud saya. Okay, lagi satu. Nak check betul tak formula awak ni biasanya. Kalau you perasan dia punya pattern. So, ini biasanya kalau you malas nak panjang macam ni, you can have just a short form. ZX and then XT. Plus ZY, YT. Also acceptable. So, you can see the pattern here. So, what I mean by pattern. So, ZX and then X. Dia mesti ada kesinambungan. ZX and then XT. Kalau, then the second term Y pula. And then YT. You must have the similar variable. But this one, yang kecil ni representing subscription, which means that the partial derivative. But you kena ambil function x, you kena differentiate tak directly. Yang ni pula zy and then y. You tak boleh tiba-tiba zx and then you darabkan dengan yt lah. So dia dah tak betul, so salah formula tu Tu cara you nak double check whether your rule or your formula is correct or not. Boleh faham? Okay, tak apa. Ini baru satu contoh. So, kita tengok apa soalan tu yang berkaitan dengan yang case ni. Ini untuk dua variable, satu parameter. Dua variable, so dalam each variable there is one single parameter t. Okay, for example, this one. So you have two variable. Under the f or under the z, there is x and y. Each x and y represented by different function in terms of t. Dia berbeza. Then find dz over dt. So gunakan formula tadi lah. Okay, so here we have the function. The function is given by x cubed y4. And x is given by t square. And then y is given by t cubed. You have to obtain the dz over dt by using this formula. So you have to obtain before you obtain the result, you have to compute 4 terms here. You kena cari 4 benda tu lah. Zx, and then xt, and then zy and yt. The derivative. Okay, so here you have f. F, you have to differentiate. Remember I mentioned before this, z or f, they are the same. F ke, Z ke, dia sama Maksud F tu maksudnya fungsi tersebut lah, function tersebut. Z is, as you know, Z representing two variable function. Okay, so here you have, because they give you F, so we use F. Find the partial derivative F respect to X. So here, Y constant. So you cuma ada 3 X square, Y4. And then, because from the formula, you also need the Fy. So we compute that straight away. Fy, so you got 4 x cubed y cubed. Okay, that is two things. And xt and yt. So you just ambil x here, differentiate terhadap t. So you have xt. So you got 2t here. And then yt, use the y function. And you got 3t square. So now you got four things that are needed in the chain rule, in the formula here. So you just multiply them. So the question is df dt or dz dt, in this case dz dt is, so you substitute zx or fx, zx or fx the same. So 3x square y4 times xt, so times 2t, plus, so you go to the second term, zy. So find your fy here. So you have 4 y cubed x cubed times yt. So yt 3t square. So that is your result. Okay. You might wonder, you might asking me, do we need what kind of your final version of exception that you have to leave? Okay, so if the question just say like in the slide, you just minta you find the dz over dt. So actually you can leave your answer with the combination of the x, y and t. Tak ada masalah. Tak salah kalau you tinggalkan jawapan awak dalam sebutan macam ini saja. Unless they say that leave your final solution in terms of t. Maksudnya you kena replace semua x dengan y yang you ada. Contoh x squared ni, so you kena masukkan x jadi x squared, so t4. So all the x, y you have to replace by t and your final solution must be must be in terms of quality. Itu kalau soalan akhir dia ada minta leave your final solution or leave your answer in terms of T. So you kena pastikan jawapan akhir awak cuma T sahaja. Tapi dalam kes ni tak mention, so you can leave your answer just like this. So it is acceptable. So tak salah lah sebab sometimes it will take maybe 5 minutes for you to substitute and simplify. So kalau dalam soalan tu tak ada mention, leave your answer in terms of T or something related to that. So you don't waste your time to give the form like this. Kalau tengok dalam soalan ni dia tinggalkan sebutan T saja kan. But if they ask for it, then you have to. Kalau you tak buat, you kena tolak markah. Okay? Sebab it's quite some expression quite tedious for you to substitute and simplify just in terms of T or just parameter they ask. Okay, faham maksud saya? But sometimes they just ask you to evaluate. So for example, using this one, so find the dz over dt. So dia bagi you kat point, specific point. Contohnya, x sama dengan 0, y sama dengan 1 for example. So you have to evaluate. So your final solution must be a number. So we don't bother about what kind of expression that you have. T sahaja ke, x, y, t ke. Asalkan you bagi saya jawapan akhir dalam nilai. Sebab dia minta you evaluate. So kena faham. Sebab tu saya kata sebelum menjawab, baca arahan. Okay. Supaya you tak membuang masa. Ataupun tak tertinggal benda-benda yang dia minta. Okay, faham So macam dalam kes ni, so you kena masukkanlah semua ni. Sebab ni saya bagi contoh lah. So you have to replace the x squared. So x is t squared. So you got this. And y is t cubed. And then to the power of 4. And so on. So then you have to expand each of them. And at the end you have to simplify. So you got this answer. Okay, so hopefully now you understood enough of another story of the chain rule, which is not so easy compared with the previous one. You have to be able to develop the chain first, and from the chain you will be able to construct the rule. So you tak payahlah hafal yang panjang-panjang tadi ya. You don't need to memorize this. Because this is very simple. Very simple. Even you without chain pun, kalau you faham, you boleh tahu formula ni. So dalam exam, tak ada extra markah untuk chain ni. Tak ada markah extra lah. Cuma, katalah kalau you buat, you bagi saya chain ni, tapi macam mana cakap So you bagi saya jawapan, you punya formula salah. So you punya, kalau formula you salah, formula tu maksudnya you apply the wrong formula. So your final outcome should be wrong, betul tak? Salahkan semua. Tapi katalah you so bila jawapan semua salah, so saya patut penalize you lah sebab you formula salah kan. And maybe I just let's say it is 5, so I can just give you 1 because you have tried. You try to give the formula but it is wrong. But katalah you provide me, walaupun semua salah, tapi you provide me the chain here. So maybe I can give you at least 2 marks. So meaning that you construct the correct chain. However, your rule is not correct. So at least daripada chain yang you buat tu, yang you develop tu, membantu you untuk dapatkan markah lebih lah. Cuma saya nak bagi tahu awal lah dalam skema jawapan tak ada markah untuk tunjukkan chain tu Okay, cuma kalau saya memang minta student buat chain ni. Dia tak susah sebenarnya, just untuk guide awak dapat formula yang betul saja. Dia membantu awak walaupun tak ada markah kat situ. Okay. Okay, I have a question for this one. Soalan yang sama. Cuma katalah, can we differentiate this? Can we obtain the dz over dt without chain rule? So this one using chain rule. This is all using chain rule. You dapat jawapan 18t to the power of 17. But can we find the derivative without chain rule. What do you think? Boleh tak? Kita dapatkan 18T7 yang kat bawah ni without chain rule. Anyone can give your your opinion. Boleh ke tak boleh? Tanpa guna chain rule ni, we guna chain rule ni. Yang apa ni? F, X, XT, FY, YT tu chain rule. But can we solve this without chain rule? Siapa lagi sebelum panggil? Jitin. Betul ke saya pronounce? I'm so sorry.
Just plug in the value key into the formula and then straight away differentiate it.
I cannot hear you. Can you repeat?
Stuck in the and y
Uh-huh.
t square and t cube.
Yeah, you mean that we can solve without chain rule, right?
Yeah.
Yes. Okay. Your friend said that we can. Of course we can find the divisibility without chain rule. Macam mana cara dia? We just first you substitute everything here. You have x cube, right? X cube, and you substitute. Okay, let me show you here. So you substitute. So your x just now is t square. So t square cube times y is t cube. T cube to the power of 4. So you dapat berapa tu? T kuasa 6 darab dengan T kuasa 12. Okay. Power kalau dia darab, dia tambahkan. So 18. So you dapat sekarang you punya F. F now in terms of T is given by T to the power of 18. But now you differentiatekan dF over dt. So dapat apa? 18 T kuasa 17. Sama tak dengan yang bawah? Sama, and even lagi cepat. However, there is but here. Because we want to implement the partial derivative, then you have to use the chain rule. Okay, dalam exam, dia akan mention using chain rule, find the whatever related to the function given. So, if in exam, you provide me like this only, you just substitute first, and then you differentiate. This is without chain rule. Tak ada penjuru dalam ni kan? So, I will give you 0. Because the question asking for using chain rule. Even though kita tahu, as you can see, the calculation is quite long. But at least you implement the chain rule that you have learned in this course. Okay, so please read carefully the instruction. Let's say kalau saya bagi soalan macam ni, saya tak mention using chain rule. Kalau you bagi saya tanpa chain rule, so of course lah you betul. You can claim that your answer is correct. Actually correct, but without chain rule. Sebab dalam soalan dia tak mention using chain rule, so you can have the mark. But normally in exam, we make sure that we have to put the using chain rule. Okay? Faham So ada berapa soalan? Ada soalan tak? Is there any question? So if there is no question, I think that's all for today. So what's next meeting? Our next meeting is on Tuesday. Tuesday kan? So Tuesday nanti saya bagi video Boleh?
Boleh.
Alright. Okay. So if I give you video, macam biasa saya akan bagi exercise, tapi saya akan tempoh untuk you buat exercise tu panjang lah. So you boleh submit. Saya akan bagi time duration yang bit longer, so you ada ample time lah. Jangan lupa terus, sudah lah Okay, so itu saja. Ya?
Tadi saya tak sempat scan attendance.
Kejap. Dia bilang. Okay, so thank you. See you again.
Thank you, Doctor.
Doktor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doctor.
Cuti-cuti juga jangan lupa buat exercise.
Baik, Doktor.
Naik ni
Baik,
test
Doktor. Alright.
Kalau soalan tutorial tu memang saya tengok susah sikit lah. So you boleh practice dulu dengan sample exam question tu.
Thank you, Doktor.
Welcome.
Thank you, Doktor.
Cakap tadi, hanya sebab saya cabut. Boleh ulang balik? Tak ada eh? Macam saya dengar dia. Dia yang bertanya tadi.
Okay, thank you, Doktor.
Welcome.